This is problem 4 of the 2026 AIME 2. Now, for this question, we are given that for each positive integer n, f of n can be defined as let b be the least integer strictly greater than the largest digit of n. We can interpret the base 10 digits of n as a number written in base b, and f of n is that value in base 10. The example given by the question is when n equals 72, largest digit will be 7, therefore b is 8. So f72 equals 7 times 8 plus 2, which is 58. Now we are asked to find the number of positive integers n that are less than 1,000, such that f of n equals n. Now the first step is to compare bases. So if we let n have digits in base 10, then it will be by definition it will be f of n, which is where then b will have to be the largest digit of n plus 1, right? So b equals largest digit plus 1. Now we have to find when can f of n equal n, right? So that's what we're trying to find. So if b is less than 10, then for any number with at least 2 digits, b to the power of k has to be less than 10 to the power of k. Therefore, f of n will be smaller than n. So that's impossible for multi-digit numbers when b is less than 10. Therefore, for multi-digit numbers, we must have b equals 10. And since b equals largest digit minus 1, plus 1, then largest digit will be b minus 1. In this case, 9. Now, we need to look for the numbers that contain 9. So we can count positive integers less than 1,000 containing at least one digit 9. So for every number from 1 to 999 that can be represented as a 3-digit string with leading zeros allowed, 000 through 999, there are 10 times 10 times 10 such possibilities. So we can count those with no digit 9s. Each digit can be 0 to 8. Therefore, 9 times 9 times 9 is 271. So there are 271 multi-digit solutions. However, we have to consider the one-digit numbers. So if n has one digit b, then equals d. Since the value of any single digit is the same as since the value of a single digit is the same in any base greater than it, f of n will equal n. This works for n all the way from 1 to 8. But does not work for 9, because I would force b equals 10, which falls under case 1 already. So therefore, there are 8 such numbers. Now we just have to add 271 plus 8, which gives us 279, and that's the final answer.